Okay, these are the video notes for the 6 basic trigonometric functions. Okay, this is the beginning of Unit 5. So, bell work, use the Pythagorean theorem to find the missing side of the given triangles. Okay, we got 4 of them. Number 1, okay, it's important to remember which value is A, which one's B, which one's C. The only one that really matters is the C value, because the C value is the side that is the slanted side of a triangle. Okay, so number 1, we have the value of A and B. We do not have C, so we have to find C. Okay, so 6 squared plus 11 squared equals C squared. 6 squared is 36 plus 121 equals C squared. If you add 36 and 121, we get 157 is C squared. And again, we're trying to solve for C, so we have to take the square root of both sides. And again, we're paying attention to the fact that now we have to figure out if 157 is a perfect square or not. Okay, we have 144 as a perfect square, that is 12 squared. We have 169 as a perfect square, that is 13 squared. So 157 is not a perfect square. However, you then need to find out if you have any perfect square factors of 157. Okay, so I'm going to go through the perfect squares. If I take 4 and I divide 157 by 4, that does not come out to a nice number. Okay, 9 is the next perfect square. 157 divided by 9 is not a nice number. Go up to 16 now, because 4 squared is 16. If I divide 157 by 16, also not a nice number. Okay, and so on. There are not any perfect square factors in 157. So my answer here is the square root of 157 equals C. Okay, number 2. Now that I have the slanted side, this is now my C value. Okay, so I'm going to plug in, and it doesn't matter if I plug in 45 for the A or the B, you're going to choose one, it doesn't matter. So I'm going to plug it in for B. A squared plus 45 squared equals 117 squared. If I take 45 squared, I get 2,025, so I have A squared plus 2,025 equals 117 squared is 13689, 13,689. I'm going to solve for A squared, so I need to subtract 2,025 on both sides. That's going to give me A squared is equal to 11,664. I'm going to take the square root of both sides, again trying to get rid of that square there. And if I take the square root of 11,668, you'll find that it's actually a perfect square. You should get 108. Number 3, okay, again I have a value of A and B. I do not have the slanted side, so I don't have C. So if I take 7 squared plus 7 squared, that equals C squared. Gives me 49 plus 49 equals C squared, or 98 equals C squared. I'm going to take the square root again on both sides. I'm going to flip this so that I can do some work here. So I have C equals the square root of 98. Okay, and again, we're going to try to simplify this because 98 is not a perfect square. Okay, just below that is 9 squared, which is 81. Just above it would be 10 squared, which is 100. Okay, so 98 does not fall in that realm. So we have to find out if we have any perfect square factors of 98. Okay, if you go through the list, I end up with the square root of this is 49 times 2. And then the square root property allows me to say the square root of 49 times the square root of 2, which then the square root of 49 is 7, and then the square root of 2 just stays the same. So my answer for C here is 7 square root of 2. On number 4, again, I have a C value. I don't have this other letter. I can be A or B. Again, for the same purposes of like number 2, I'm going to go ahead and stick that with an A. So I have A squared plus 72 squared equals 75 squared. If I take 72 squared, I get 5,184. If I take 75 squared, I get 5,625. And then again, I'm going to solve. So I'm going to subtract 5184, which gives me A squared is equal to 441. And then again, I'm going to take the square root of both sides, which gives me A is equal to just 21. Moving on. For this section, you're going to have to know how to use Pythagorean theorem. So obviously, if you went through the bell work there with no problems, then you shouldn't have any issues with this unit as far as the Pythagorean theorem goes. Yes, there's obviously a little bit more to this, but you do need to know the Pythagorean theorem. Okay, so recall Pythagorean theorem is A squared plus B squared equals C squared, where typically the A is the smallest leg, B is the largest leg, and C is the hypotenuse. Again, C has to be the side that is opposite of the right angle. Okay, these are all right triangles. And you're going to use it whenever you're missing one of the lengths of a right triangle. So you are going to be given 2 pieces of the right triangle. You have to find the third. For the sides of a triangle, you're going to have to find 3 kinds of sides here. You're going to find the opposite side, you're going to find the adjacent side, and you're going to find the hypotenuse. Okay, not so much as find, but as to label. Okay, I'm going to tell you to either use angle A or use angle B to set up these ratios. And if you look at the left-hand triangle there, I'm saying we're going to use angle A. All right, and you'll find me a lot of times when I go through here, if I say to use angle A, what I'll do is I'll start with angle A and I'll do a line and draw an arrow. Okay, that just tells me every time which one is my opposite side, and I'm going to write OPP next to that. Okay, the hypotenuse again is always forced. That is always your slanted side, HYP. And then the other one is then your adjacent, ADJ. Okay, on the bottom right-hand triangle, if I said to use angle B, and I wrote angle B down there in the bottom right-hand corner, then I would do again the same thing here. I would draw an arrow to my opposite side and label it as such. Okay, understand, when I give you the homework assignment, what you're going to end up with is a couple blank triangles for each problem, one for each problem. And you're going to label it however you want to label it. Okay? To stay consistent, when I label with right triangles, I will always put A in that top left corner like it is on the board there. And I will always label B in that bottom right-hand corner, like it is on the board. Okay? Angle C is always that right angle. Okay, parts of a triangle. There are 3 angles of a triangle. Again, they add up to 180 degrees. But again, that's not for the purpose of this section. If you look at the top right-hand corner there, I also labeled it different than I said I would. So let me go ahead and change that actually. What I would do always would be I would have this as my angle A. This would be my lowercase a. This would be my angle B. And this would be my lowercase b. Okay, that then contradicts what I say down below, where I say it's typically the largest side or typically the smallest side. Okay, but again, that's not really a big thing. That's just something that typically has happened in past textbooks. Okay, but that's not highly important. All that really matters is that you have an uppercase A for the angle. Opposite of that is the lowercase a, which is the side length. You have to make sure that you pay attention to uppercase and lowercase letters here. If you have an uppercase letter, you are talking about an angle. If you have a lowercase letter, you are talking about a side. Okay? If you get them interchanged, they will be incorrect. So make sure you pay attention to that. The 6 basic trig functions that we're going to talk about, the original 3 are sine, or as it's going to be denoted, and you've seen it on a graphing, or a scientific calculator, you would see this as sin. Cosine you've seen as cos. Tangent you have seen as tan. The 3 reciprocal functions you have not seen, however, those are, again, the reciprocals, which means you have 1 over sine, or 1 over cosine, or 1 over tangent, okay? Those are going to be denoted as cosecant. That is 1 over sine. That's why they're labeled 1 and 1. So this is the same thing as saying 1 over sine, which we're going to write as CSC. Secant, or 1 over cosine, is going to be written as SEC, secant. And cotangent, which is 1 over tangent, is going to be written as COT, cot. Okay, so for each of your problems, you're going to have to do actually 7 parts. Part 1 will involve doing the Pythagorean theorem to find the remaining piece that is missing. And then parts 2, 3, 4, 5, 6, and 7, you're going to find the ratio for sine, cosine, tangent, cosecant, secant, and cotangent. Okay, lots of work involved. The original 3 functions, my suggestion for all of you would be at the top of any paper in which you are working with trigonometric functions and setting up ratios for sine, cosine, and tangent, is that you would write SOHCAHTOA at the very top of your paper. Okay, that is again SOHCAHTOA, SOHCAH, and TOA. That just means SOH, sine of the angle that we're looking at. So here I'm saying using angle A is equal to the opposite over the hypotenuse. So this tells you which trig function we're using, and this too tell you which sides we are using, okay, for my ratio. Important things to note: make sure that next to sine, cosine, tangent, cosecant, secant, and cotangent, that you have the capital letter of the angle that we are using. Okay, so again here I'm saying I'm using angle A, so that's why there is sine, capital A, cosine, capital A, tangent, capital A. Behind that uppercase A, you need to make sure that you have an equal sign. So things that I see all the time, people put a colon or they just put a dash. Okay, if not an equal sign, it will be incorrect. Okay, so make sure you pay attention to those things that are very, very common from what I see. Moving on to CAH, cosine of the angle, again equal, adjacent, divided by the hypotenuse. Okay. tangent of the angle is equal to the opposite divided by the adjacent. Okay, again, so, ka, to. It sets up your ratios for you. Next page here, looking at the reciprocal functions now. Again, they are the reciprocal of sine, cosine, and tangent. So if you think back, and I rewrite up at the top here, so, ka, to. And I think about cosecant as being the reciprocal of sine. Then what you're going to do is look at sine and flip it. That's what the reciprocal means. So if sine is the opposite over the hypotenuse, then cosecant of the angle is equal to the hypotenuse divided by the opposite. Okay, again, the reciprocal. Secant is the reciprocal of cosine, and cosine is the ca, C-A-H, which means I had cosine as the adjacent divided by the hypotenuse. So if I flip that, I have the hypotenuse divided by the adjacent. And then cotangent is the reciprocal of tangent, and tangent is toa, T-O-A. So tangent is the opposite over the adjacent. So the reciprocal of that would then be the adjacent divided by the opposite. Important note here, rationalizing the denominator, you need to remember that you may not have a non-rational item in the denominator of a fraction. That means you cannot have a square root and you cannot have an imaginary number. You cannot have an I or a square root. Okay, for the purpose of this, if you have a square root in the denominator, you're going to need to multiply the numerator and the denominator, okay, the top and the bottom of the fraction, by that square root, okay, so that we can simplify. Okay, so here I have two examples. I'm actually going to modify the second one for the purpose of trying to think about one of the worksheets that we have and the fact that I give it a little bit different. So I'm going to work these out each individually. There's not enough space on one side of the board for me to work them out as both holistically on the page. So I'm going to work out number one first, and then I will delete the board, and then I will go back and work out number two. But again, I'm going to modify number two a little bit. Okay, so starting with number one, I'm going to give you again a triangle that looks like this. It's going to be 100% blank. You choose to label it as you want or not. That's up to you. And I'm going to label this as angle A. This is angle C. This is angle B. Again, make sure that they are the uppercase letters because those identify the angles. Side A is opposite of angle A, which is 10. B is opposite of angle B, and that's 15. Okay, we don't know the value of C, so we have to find the value of C first. So that comes to that Pythagorean theorem. So here again, A squared plus B squared equals C squared. I know that this is 10 squared plus 15 squared equals C squared. 10 squared is 100. Plus 15 squared, which is 225, is C squared. Combine those two, you get 325 equals C squared. Again, 325 is not a perfect square, so when I take the square root, I have to then try to simplify things. So when I do that, again, I'm going to go through all the factors and try to find out which one is the largest perfect square factor. Okay, and again, for the time purpose of this video, we're going to just go ahead and break it down. 325 is 25 times 13 equals c, because again, the c squared and the square root will cancel each other. The square root of 25 is 5, so we have 5 square root of 13 is my value of c. Okay, and again, that is only the first part of this problem. You have to then identify all 6 of the trig functions. Okay, so again, now it says use angle A here in the directions. I'm going to label this as my, again, opposite now. This is my adjacent, and this is my hypotenuse. Okay, so if I'm going to set up the trig functions, I'm going to start with sine, and then move on to cosine, and then the tangent. Okay, but I'm going to do the original 3 first. So if I go back, let's go ahead and use green here. Sine of angle A, because again it says use angle A, equals opposite. Okay, so if I write, again, SOHCAHTOA someplace here, let's write it, let's say here, SOHCAHTOA. Then sine of angle A is the opposite over the hypotenuse. Okay, you don't have to write OPP over HYP every time. Some of you may want to, just for the purpose of remembering what it would be. Okay, but if I'm going to plug in, then what's the opposite? The opposite here is 10. So it's 10 over the hypotenuse, which was 5 square root of 13. Okay, so we have a couple of issues to pay attention to. One, can I simplify this? Do I have a fraction that I'm able to reduce and make it a little bit more simplistic? So 10 over 5 can be reduced. I can divide 10 and 5 by 5. So I'm going to simplify there first. That would then give me 2 over the square root of 13. The second issue is then that I cannot have a square root in the denominator. So again, on the previous page, I said you have to rationalize the denominator. And in order to do so, you're going to multiply the top and the bottom by that square root that's in the denominator. So I'm going to take this here and here and multiply by the square root of 13. Okay, and the way this works here on the top, square root of 13, think about like a variable. If this was 2 times x, you would just have 2x. I cannot take that 2 and work it underneath the square root. So this just becomes 2 square root of 13. And the denominator, the way this works is square root of 13 times the square root of 13 becomes the square root of 13 squared. And squareds and square roots will cancel, which gives me just 13. Okay, now I can't simplify 2 over 13, and the square root of 13 is just kind of stuck in limbo there, so that is my answer. Moving on then to cosine of A. Again, looking at this SOHCAHTOA there, CAH means the adjacent divided by the hypotenuse. Which again, if I use what I have up here, the adjacent is 15 over the hypotenuse, which was 5 square root of 13. Okay, so again, the question is then, how can I reduce this, or can I simplify it all? 15 over 5 I can reduce, and that becomes 3 over 1, because I can divide by 5. So 3 over 1, or just square root of 13. Again, now I have to rationalize the denominator, so I need to multiply the top and the bottom by the square root of 13. Which gives me now 3 square root of 13 divided by 13. And then tangent TAN of A. Again, pay attention to the TOA there. TAN of A is the opposite divided by the adjacent. Opposite here is 10 over the adjacent, which was 15. And this one I can reduce now to become 2 over 3. Okay, you'll notice with these sine, cosine, and tangent, I showed quite a bit of work for sine and cosine. And the purpose of that is, again, when the last 3 come into play, again, they are the reciprocal functions. So ideally what I would be able to do is backtrack into some of my work and then take one of the fractions that I already have on the board and just flip it. Okay, so if I take the answer for sine and I flip that, I'm going to put a square root back in the denominator. Okay, and again, I would have to then rationalize the denominator and give myself extra work to do. Okay, but if I backtrack and I continue backwards, square root of 13 here and square root of 13 in the orange was just used to simplify. Okay, but if I take this fraction here and I flip it, that gives me something that I don't have to simplify. It's already done. So then here I have CSC, or the cosecant of A, is equal to taking this and flipping it, the square root of 13 over 2. Done. With a similar fashion for cosine, I'm going to work my way back through the work. If I take this and flip it, I'm going to put the square root in the denominator, which would be a problem. Again, these orange square root of 13s were just simply used for simplifying. But here, I can take this and flip it and be done. So secant of A is equal to the square root of 13 over 3. Finish. Cotangent of A, or the reciprocal of tangent, I take the answer here because I don't have any square roots left, and I flip it, I get 3/2. Done. Okay, can you write that as a mixed number if you want? Yes, but I don't really care too much for mixed numbers. Improper fractions reduced would be the best for me. Okay, but as long as it's equivalent, I would take it. Okay. Number 2, again, I'm going to modify this a little bit so that we can see something. I'm going to change this B. I'm going to change this B to be C equals the square root of 29. Okay. And again, I'm going to work then the Pythagorean theorem on this side of the board. So again, I'm ignoring number 1 here. I'm working solely with number 2 now. Okay, I have A squared plus B squared equals C squared. I know the value of A and C, so I'm going to plug in for those. So I have 2 squared plus B squared equals square root of 29 squared. Okay, and remember again, when you square a square root, what happens is that the square root in a square just cancel each other out. So here, this and this will cancel. 2 squared is 4 plus b squared, which is now just 29. I'm going to solve for b, so I'm going to subtract 4 on both sides. B squared now is 25. And if I take the square root of both sides here, I find that b is 5. Okay, so this was the original problem that I gave anyway. However, I wanted to make sure that I showed you a case where I took the square root of something as a given value of one of the sides. Okay, you will have some cases where I do that. So make sure you pay attention to that. Another thing you can do is when you see something like that, remember that something squared is taking it times itself. Okay, so if I gave something like 3 square root of 5, I could rewrite it as 3 square root of 5 times 3 square root of 5. Okay, and then work it out mathematically. All right. Again, now labeling my triangle, I'm going to do angle A up top, which gives me side A down here, which is 2 as we identified. This is angle C, the right angle. C is the square root. I like the way that looks. C is the square root of 29. This is angle B. B was then 5 as we just found. Again, I'm going to label them now again because I'm using angle A. This is my side A, which is my opposite. This is my adjacent. And then this is my hypotenuse. Okay, and again, working with so toe. So starting with sine of angle A is equal to the opposite, so 2. Let's go ahead and write it again. Opposite over the hypotenuse, which is 2 over square root of 29. You'll notice here that we don't have a number on the outside of the square root of 29, so I cannot simplify. So I need to go ahead and start right away here. I'm going to multiply the top and the bottom to rationalize by the square root of 29. Which gives me 2 square root of 29 over 29. Moving on then to cosine. Cosine of A was the adjacent divided by the hypotenuse. Which is 5 over the square root of 29. Again, I need to rationalize the denominator. So multiply the top and the bottom by the square root of 29, which is going to give me 5 square root of 29 divided by 29. Tangent of A is the opposite divided by the adjacent. The opposite here is 2. The adjacent is 5, so it's 2 over 5. And you can't simplify that, so it's done. Okay, then again, moving on to the reciprocal functions, cosecant, secant, and cotangent. So cosecant was the first one. And that's the reciprocal of sine. So the reason that I write these out the way I do is because they are the reciprocal. I can just look left to right. Cosecant was the reciprocal of this. So if I take this and I flip it, again, I'm going to put that square root in the denominator, which would be a problem. So I'm going to continue to backtrack. If I go to here, this was just to simplify. However, if I go back to this next one here, take this and I flip this, I get the square root of 29 over 2. and I'm done. Moving on to secant, or again the reciprocal of cosine, SEC of angle A. If I take this and I flip it, then that's going to put that square root in the bottom, which is the problem. This was again used to simplify, so I don't worry about that. But here, flip that, I get the square root of 29 over 5. And then tangent's reciprocal is cotangent, COT, of A is equal to 2 over 5, which then is 5 over 2 as its reciprocal. Okay. Be careful to note that at times you will have to put a square root in the denominator. So let's say that I had this for sine. In order to do cosecant, then I would have to flip that. I would be forced to put that in the denominator, which is okay. That just puts me then at this situation, and I would have to simplify and then work it down. Okay. Nicely enough here, for my original functions, all that stuff was in the denominator right away, so that at the reciprocal functions, I didn't have to worry about doing that. Okay, but you will have to do that once in a while. All right. Again, then that's the conclusion of this lesson. If you have any questions, comments, or concerns, please by all means feel free to reach out to me and let me know.